So we're going to prove that the limit as n approaches infinity of the greatest integer of 10 plus n over 2n is equal to 0, where of course the greatest integer function of x is for all x contained in the real numbers. So the way the greatest integer function works is our input can be any real number, like let's say 2.8, and it'll give us the greatest integer that is less than or equal to 2.8, which in this case would be 2, right? Another example could be the square root of 2. We know that that's approximately 1.41, so the greatest integer that is less than or equal to the square root of 2 is 1, and so on. Okay? So now that we have an idea of how the greatest integer function works, let's go ahead and get started on this proof. So proof. So remember, if we want to determine that a sequence converges to a certain limit, we have to show that for every epsilon bigger than 0, there exists a capital N contained in the natural numbers where little n bigger than or equal to big N implies that the absolute value of the terms after this capital N, right? 10 plus n over 2n, greatest integer minus 0 is less than epsilon, right? So we want to show this. So we gotta, so let's go ahead and let epsilon be bigger than 0 and choose. So let's find that capital N that'll help us get to our desired conclusion. So if we were to plug in 10, so let's just go ahead and look at this really quick. So 10 plus n over 2n, right? So if we were to plug in 10 instead of n, right? So 10 and then times 10, we'd get 10 plus 10 over 2 times 10, which is 20 over 20, which is equal to 1, right? Which of course the greatest integer of 1 is 1. So that's not going to be, we don't want our n to be 10, but let's think of anything after 10. So let's go ahead and erase this and try 11, okay? Let's go ahead and get all this out. So let's get 11. So 11, 11, 10 plus 11 is 21. 2 times 11 is 22. So now the greatest integer that is less than or equal to this real number is 0. And let's go ahead and do 10 plus 12 over 2 times 12. Hopefully you guys can see that. So this will be 22 over, well, of course, the greatest integer of 22 over 24, right? So the greatest integer of this is 0 as well. So it appears that every n after 10 will go to 0, which is what we need. So let's go ahead and get rid of this, and we'll choose our n and choose capital N to be bigger than 10, right? Because for 11 it went to 0, for 12 it went to 0, and for all of them after 10 they will go to 0, because you'll always have a bigger denominator than numerator. Okay, so let's go ahead and suppose that little n is bigger than or equal to big N. This implies that n is bigger than 10. So this implies that the absolute value of 10 plus n over 2n, right? The absolute value of the greatest integer of that minus 0 is equal to the absolute value of 0 minus 0, which is 0, which is we know is less than epsilon. So we got n, after assuming that n was bigger than or equal to big N, we got that the absolute value of 10, the greatest integer of 10 plus n over 2n, right? Minus 0 is less than epsilon, which this shows that the limit as n approaches infinity of the greatest integer of 10 plus n over 2n, right, is equal to 0. And that is our